Hello. Today we'll present about statics mini project. Before we start our presentation, I would like to introduce myself. My name is Sharmaragan, son of Murali. Matrix number B0819100045.
Hello, and my name is Rishidharan Gnanasegaran, and my matrix number is B0819100423. Okay, so my friend Sharmaragan will continue from here.
Okay, now we'll start our presentation. Before that, I would like to share my screen to continue with our presentation. Right. Can you see the screen?
Yes, yeah.
So the title that we choose for our mini project will be Cutter. From this tool, there are three number of systems in this cutter. The first system is the whole cutter system, which includes the upper jaw, lower jaw, and upper arm and lower arm with the grip plant. And the system 2 will be the grip plant system. And our third system will be one part of the cutter, which is upper arm and the lower jaw. So this will be the model for each system. For the first system, the whole plier system, and our system 2 will be the grip stem. This will be the dissectional part of the stem, and the third system will be upper arm and the lower jaw. Now the free body diagram with all forces of the equipment that we took. The first diagram shows the upper arm and the lower jaw of the cutter. The alphabet B shows the front size of the cutter, and the distance A shows the arm size of the cutter, and Q and P will be the force acting on the cutter. Same goes to the lower jaw and the upper arm of the cutter. On top right will be the free body diagram of the center pin of the cutter, where the forces are acted. And our fourth diagram will be the free body diagram of the grip stem, where there are four forces acting on the grip stem. Now, my friend Rishi will continue with the presentation.
Okay, Sharma, thank you. I will take from here. Okay, so I will tell about the equilibrium equation. Okay, so the equation for the pin is three equation, and there are four unknowns, which is known as Rx1, Rx2, Ry1, and Ry2. Next, there is the equilibrium equation for the stem. So there will be three equation and four unknowns, which is N1, N2, and F1, F2. Okay, so the equilibrium equation are below with the overall forces equation. Okay, so analysis of the forces acting on the structure. Okay, so analysis of the forces acting on the structure. So when the forces is shift to the right, so the total Fx equals to 0, whereas Rx1 minus Rx2 equals to 0, and Rx1 is equal to Rx2 and equal to 0. So when the force is up, so the total force Y, Fy, equals to 0, where Ry1 minus Ry2 equals to 0, and Ry1 equals to Ry2. So from the second diagram here, you can see that this is the forces on the pin, where Ry1 is from the body, and Ry2 and Rx1 and Rx2. Okay, so next we will move to analysis of the forces acting on the structure. Okay, so the total moment equals to 0, where negative F is equals to 1. Okay, and so where F1 equals to 0. So when the force is shift to the right, total Fx equals to 0. So F1 plus F2 equals to 0. So we can conclude that F2 equals to 0. And when the force is up, so total Fy equals to 0, and n2 minus n1 equals to 0. So we can come out with the equation of n2 equals to n1, which is equal to n. Okay, so since spin is assumed as since spin is assumed to attach at B1, Rx and Ry shown are from B2. Okay, so when we shift to the right, total fx equals to 0. So negative fx equals to Rx equals to 0. So from there we can get a equation of Rx equals to 0. So when we have on up, ny plus Ry plus 10. Okay, so first of all, sorry, I should have explained about the diagram. Okay, so we have the diagram with the measurement, which is 2 inch from the tip of the cutter to the mid of the cutter, which is the nut is located. Okay, the nut, the pin. Okay, so and then from the pin to the end of the cutter, it is 4 inches long. So we label as the the cutter with N1 and the pin as RY and RX, okay, on the Y and X axis, and 10 pound of force is acting on the end of the grip, on the end of the holder. So we are applying 10 pound of force. Okay, so with that, when we shift to the right, the total Fx equals to 0. So we can conclude that Rx equals to 0 from that equation. And when the force is on up, N1 plus Ry equals to 10, plus 10 equals to 0. So from there, we can conclude that second equation is Ry equals to negative 35. And the total moment equals to 0, which is negative N1 times 2 plus 10 times 4. So which we can get the third equation, N1 equals to 20. Okay, so Sharma next.
So
Okay,
that's all
so that's
for
all from both of us. And I hope you had enjoyed our presentation. So thank you very much.
right. Thank you.